to the our unit optics. As you know, we were doing the unit optics and we have covered complete 2 chapters of the unit optics. Reflection and refraction we have done. Now our third chapter of optics is dispersion of light. This is the third chapter of optics. This is C part of optics, dispersion of light. And the first topic in dispersion of light is refraction through a prism. Refraction through a prism. How phenomena of refraction takes place through a glass prism. You know what is a prism? This is a prism and this is made up of material of some medium. Glass का है तो material होगा. So ये आपने यहाँ पे एक prism लिया है and this prism, you know the refraction, this prism has 2 refracting surfaces. This is surface AB, at whenever the ray coming from a rarer medium to the denser medium, this prism will act as a medium. So the ray traveling from rarer medium to the denser medium. So at this surface refraction will occur. While going out of the prism, this ray at this point again there will be refraction. So at both the phases AB and BC phases of this prism, refraction occurs at both these 2 phases. So we have to study the refraction through a prism. So this is a prism. ABC is a prism. A is the angle of prism. This is angle of prism. AB and AC are the 2 refracting surfaces. AB and AC are 2 refracting surfaces of prism. Okay. Prism की 2 refracting surface हो गई. Suppose this is an incident ray. KL is an incident ray. When this ray falls on the first refracting surface AB at point L, it is traveling from rarer medium to the denser medium. We will draw a normal at this point and this ray will bend towards the normal. इसका path ऐसे होना चाहिए था. This should go like this, but ऐसे ना जाके it bends towards the normal. So this is the path of the ray traveling in the medium. This is incident ray, this is refracted ray, and this ray is known as emergent ray. So the incident ray falls on this surface and the angle making with the normal is known as angle of incidence, and this is angle of incidence I1. So the angle between refracted ray and the normal is angle R1. When this ray falls at this surface AC, and you know this is also a refracting surface, so we will again draw a normal, because now the ray will go out of the prism, and while going out of the prism, this ray travels from denser medium to the rarer medium. So you can see here, this should be its path. ये अपने path से normal से क्या हो गई है, अवे बैंड हो गई है. अगर नॉर्मल की तरफ बैंड होती तो ऐसे होना चाहिए था. Because this is going from denser medium to the rarer medium, it bends away from the normal and it goes out from the medium at an angle of I2. So this is the scenario. Now we have to do one thing. If I produce the path of this incident ray in forward direction, अगर यहाँ पे रिफ्रैक्शन का फिनोमेना नहीं हुआ होता और इस इंसिडेंट रे ने अपना पाथ चेंज नहीं किया होता, इन दैट केस जो इंसिडेंट रे का पाथ है दैट शुड लाइक दिस, and if I produce the path of emergent ray backward, then there is the angle between the two rays, and that is known as delta, and this angle is known as angle of deviation. Angle of deviation. This is the incident ray. This should be the path of incident ray, but because of the phenomena of refraction, this incident ray is going in this direction. If I produce its path backward, so these two rays meet at this point, and there is an angle between the two rays, and that angle is known as angle of deviation. What is angle of deviation? Angle of deviation is the angle between the original path of the incident ray and this ray. So angle of deviation is that angle through which the path of original path of incident ray has been deviated. इतने एंगल से जो ओरिजिनल रे है has been deviated. इतना एंगल आ गया है डेविएशन का, मतलब रे को ऐसे जाना चाहिए था, but now it is going in this direction at this path. So this is the angle through which incident ray has been deviated through its original path. So I am writing the definition for delta, angle of deviation. Angle of deviation is the angle through which incident ray has been deviated from its original path. So this is about the angle of deviation. Now, while doing the derivation for refraction through a prism, we have to find out this delta. How can we find this delta? This is the total deviation occurred in the path of incident ray. But if we see at this phase, here at this phase first refraction will occur, and at this phase of the prism second refraction will occur. At the first refraction, how much is your incident ray has been deviated? This ray should go like this, but it has deviated through an angle. This much angle is the angle of deviation at first surface. So this is the angle between this angle of deviation has been occurred at the first surface. So I am deriving the derivation for angle of deviation. At first surface, we will start our derivation like this. At first refracting surface, and that is AB. फर्स्ट सरफेस के ऊपर जो एंगल ऑफ डेविएशन होगा, एंगल ऑफ डेविएशन is written as delta 1, and this delta 1 इतना डेविएशन हो गया है. देखो ये ओरिजिनल रे ऐसे जा रही थी, बट ये ऐसे इसको जाना चाहिए था ऐसे, बट इस डायरेक्शन में ना जाके दिस इज गोइंग इन दिस डायरेक्शन. So this much is the deviation. But how can we write this deviation? This deviation is known as I1 minus R1. I1 minus R1. This is first equation. When this refracted ray coming at this surface, second refracting surface, at second refracting surface, कौन सा? AC. Deviation is denoted by delta 2, and this is equal to, this was the ray, this should go like this, and now it is going like this. Again it bends away from the normal, that means again its path has been changed. So at this point the deviation is this much, so I2 minus R2. I2 minus R2 is the deviation at the second surface, second refracting surface AC. Now what is the total deviation faced by the incident ray? Total deviation can be denoted by delta, and that is equal to the sum of delta 1 plus delta 2. Deviation that has been occurred at AB and deviation that has been occurred at AC. So delta is equal to delta 1 plus delta 2. What is the value of delta 1? Delta 1 is I1 minus R1, I1 minus R1 plus delta 2 is I2 minus R2. I1 and I2 I can write I1 plus I2 minus, I can take minus common and it would become R1 plus R2. I hope this is clear to you. So this delta is equal to I1 plus I2 minus R1 plus R2. Now we will take the triangle ALM. I'm rubbing all these things. I'm writing this result at this place. Delta is equal to I1 plus I2 minus R1 plus R2. Now, in triangle ALM, angle A, sum of the three angles of triangle ALM is 90. Angle A plus this angle and plus this angle is equal to the 90 degree. How can we find this angle? You know, normal is making an angle of 90 degree with the surface. So this complete angle is 90 degree and this angle is 90 minus R1. In the same way, this is the normal. This complete angle is 90 degree. How can we find this angle? 90 minus R2. So, angle A plus 90 minus R1 plus 90 minus R2. 90 minus R2 is equal to the 180 degree. Now, 90 को हम उस तरफ शिफ्ट करेंगे तो it would be 0 minus 180 और ये आ जाएगा 0. Now angle A minus of angle R1 minus of angle R2 is equal to 0. Now angle A, can I write A minus R1 plus R2 is equal to 0, and I can write A is equal to R1 plus R2. This is the second result. Now I can change this formula. I can replace R1 plus R2 by A. So delta, that means deviation, angle of deviation comes out to be I1 plus I2 minus A. So this is the angle of deviation through which incident ray has been deviated through its path. So this is the angle of deviation. But this angle of deviation can be minimum. How can we minimize this angle of deviation? That means, how can we reduce this angle at which this incident ray has been deviated? So we have to reduce the angle of deviation. That means we want to make it to be minimum. So next derivation would be for the minimum angle of deviation. So वो हमें कैसे find out करना है? तो up to now we have find out the angle of deviation, and formula for angle of deviation is equal to the I1 plus I2 minus A. So let us do these two results, and angle of prism is equal to R1 plus R2. So this was the first, and second is A is equal to R1 plus R2 and delta is equal to I1 plus I2 minus A. So these are the three results we will use for the minimum angle of deviation. So next in this derivation, our next part would be derivation for minimum deviation. So angle of minimum deviation. That means how can this angle of deviation be minimum? Minimum angle of deviation के लिए we will derive the equation. Angle of minimum deviation or Prism formula. The result that will come out through this derivation would also be known as Prism formula. Now, angle of minimum deviation. That means angle of deviation is said to be minimum deviation only when there is one single angle of incidence. Delta is said to be equal to the delta minimum when there is only one angle of incidence. One angle of incidence means I1 is equal to I2 is equal to I. That means angle of incidence I1 and I2 both are equal, and we can say that I1 equal to I2 is equal to I. So this is the condition for the minimum deviation. That means the angle of deviation can be minimum only when the angle of incidence is single. That means I1 and I2 are not different. These are same. That means I1 equal to I2 is equal to I, and there is single angle of incidence. In that case only angle of deviation could be minimum. So this is the condition. When delta is equal to delta minimum, in that case I1 equal to I2 is equal to I. Okay. Now we will apply Snell's law at L and M. Simply apply Snell's law at L and M. Snell's law, when we will apply at L, we will get sine of I1 into refractive index, rarer है तो we can write 1. Then sine of R2 and multiplied by refractive index of the medium, suppose nu. As you can see that from here we can simply write sine of I is equal to sine of R2 mu. From here we can find out the value of mu as sine of I over sine of R. Now I hope you have understood. We need to find out the value of I and R now. Okay, I and R को how can we find out? See, from here, as for the minimum deviation, delta is equal to delta minimum. In that case, as I1 is equal to I, therefore R1 would also be equal to R, and that is equal to R. R1 is equal to R2 is equal to R. Because this deviation is minimum only at the condition of I1 is equal to I2 is equal to I. Therefore, R1 is equal to R2 would also be equal to the R. Now, from here, we can find out the value of I1 and I2. कैसे देखो? We know that delta is equal to I1 plus I2 minus A. From this result, we know that delta is equal to this much. I1 and I2 can be replaced by I. So delta would become 2I. Here delta would be delta minimum. Remember, we are deriving the derivation for minimum deviation. So this time delta is known as delta minimum. So delta minimum is equal to 2I minus A. From here we can find out the value of I. I is equal to delta minimum minus A by 2. This is the value of I. In the same way, we have to find out the value of R. We can find out the value of R from this equation. We know that angle A, that is angle of prism, is equal to the R1 plus R2, and we know that Because I1 is equal to I2 is equal to I, therefore R1 is equal to R2 is equal to R. So simply we can write that A is equal to 2R and R is equal to A by 2. Simply put the value of I and R in this equation and we will get the angle of minimum deviation. Now we know that mu is equal to, रब कर देते हैं यहाँ से, mu is equal to sine of I. In place of I we can write delta minimum minus A divided by 2 over sine of R. R can be replaced by A by 2. So this is the derivation for angle of minimum deviation, or we can say that this is the formula for angle of prism. So this is all about the refraction through a prism. Now we will move towards the thin prism. This was delta is equal to I1 plus I2 minus R1 plus R2. And the second was angle A is equal to R1 plus R2. And I1 plus I2 minus, this was delta is equal to I1 plus I2 minus A. So these are the three results and this is the minimum deviation. Now we will do the concept of thin prism. When a prism is said to be thin prism, a prism, thin prism. What is thin prism? How can we say that a prism is thin prism? When angle of a prism is small, then the prism is said to be thin prism. A prism is said to be thin prism if its angle of prism is small angle. So I hope you have understood there is no need to write about the thin prism. But when we will discuss about the thin prism, in that case we know that delta is equal to the I1 plus I2 minus R1 plus R2. This is the equation for delta, and second equation is delta is equal to I1 plus I2 minus A. Now we will start our derivation like this. We will apply the Snell's law at L and M. At L and M we will simply apply Snell's law. When we will apply Snell's law, we sine of I1 into refractive index 1 and sine of R2 into refractive index nu. And we know that अभी हमने किया in case of minimum deviation angle of incidence I1 and I2. अब यहाँ पे हम ये ले लेते हैं कि थिन प्रिज्म के लिए जो एंगल ऑफ इंसिडेंस है और एंगल ऑफ आपका R2 मैंने यहाँ पे गलत लिख दिया है, दिस इज R1. I1 और R1 आपके स्मॉल एंगल्स होंगे. थिन प्रिज्म है, एंगल ऑफ प्रिज्म स्मॉल है और आपके पास एंगल ऑफ इंसिडेंस I1 और R1 भी क्या होंगे, स्मॉल एंगल्स होंगे. इन दैट केस sin of I1 can be replaced by simply I and sin of R1 can be simply replaced by R1. So it would become I1 is equal to mu R2. In the same way, when we will apply Snell's law at M, we will get ray is traveling from denser medium to the rarer medium, mu into sin of R2, and this is equal to 1 into sin of I2. Again, R2 and I2 are small angles, therefore mu into R2 is equal to I2, because angle of I2 and R2 are small angles, so we can simply replace by R2 and I2. So we have got the value of I2 is equal to mu R2, and in the second result we will replace the value of I1 and I2. Okay, replace the values. Delta is equal to I1 is mu R2 plus I2 is, this is mu R1 plus I2 mu R2 and minus of A. From here delta is equal to mu R1 plus R2 minus A, and R1 plus R2 can be replaced by A. So it would become delta is equal to mu into A minus of A, and we can simply say delta is equal to A into mu minus 1. So this was the expression for the thin prism. So we would apply so now we have got two formulas for angle of deviation. This is the first formula for the angle of deviation, and this is the second formula for the angle of deviation. So where do we use this formula and where do we use this formula? This is the formula when your refracting angle is small. That means when refracting angle is small, less than 10 degree, I can see. When a refracting angle is less than 10 degree, in that case angle of deviation would be find out by this formula, and if the refracting angle is greater than 10 degree, in that case we will use the formula for angle of deviation by this. And you can see here, as I have told you, when angle of incidence, I have taken angle of incidence I1 and R1 as small angles. In that case you can see here angle of deviation does not depends upon the angle of incidence. आप यहाँ पे देख सकते हो, here delta depends upon the angle of incidence. But when angle of incidence in thin prism, I have taken angle of incidence as small angle. In that case delta is also independent of angle of incidence. In this term is not containing angle of incidence. So when angle of incidence is small, in that case angle of deviation is independent of angle of incidence. Question can be asked कि if angle of incidence is small angle, does delta depends on angle of incidence? No. You can see here in this derivation I have taken angle of incidence small, that's why I have replaced sign of I by simply I. So delta does not depends on the angle of incidence. But when I have not taken angle of incidence as small angle, in that case delta depends on the angle of incidence. So this was all about the prism, dispersion of light. In dispersion of light we have covered one topic related to the refraction through a prism, वो हमने कर लिया है. Then we have derived the formula for, or you can say prism formula we have derived. Then we have studied the case of thin prism. In thin prism the equation for the angle of deviation is mu